Hey everyone, in today's video we're going to look at a new benchmark called Long Horizon Terminal Bench. So what we're going to do is we're going to look at how they put this together, what the benchmark actually is, what a task looks like, how it's assessed, what the results are, and what we might want to learn from this. I think that all of these benchmarks are telling us something that we really need to pay attention to. AI agents are getting better, faster, and cheaper over time. Their capabilities rising, and more bundles of tasks can be pushed to them. And we're learning that as the models get better, more and more agent work in our economy is going to be done by AI agents. Tracking the progress on these benchmarks is a key way that we keep ourselves informed and understand the different performance differences between all of the different models from the different providers. This is the Long Horizon Terminal Bench, measuring the progress agents can sustain, not just what they can finish. Most agent benchmarks end in minutes. Real terminal work may not. Long Horizon Terminal Bench drops an agent into a Docker container with a goal that takes hundreds of dependent actions, build a system from scratch, migrate a real framework across breaking changes, play a game move by move, then grades it with a hidden, fake-proof verifier that pays continual partial credit. We ran 18 frontier models through the same harness. None passes even a third of the tasks. This is really interesting because that means they've set up a benchmark that's tough enough that it isn't easy for the best agents today to pass it. So this is something which means it's useful. It means for the next year or so, we'll be able to track progress. If a benchmark comes out and models are scoring really highly already, then the benchmark was probably set too easily. This is a super interesting point. Okay, so here they show how it's put together. It's an agent, Docker container, and a hidden verifier with this graded reward. The loop has to hold for 90 minutes. Okay, so it's 46 hard reproducible terminal tasks across 9 categories, designed to resist memorization, shortcutting, and reward hacking. Every task pays continuous partial credit instead of binary pass-fail. We evaluated 18 frontier models under one identical harness, Terminus 2, 1 container per task, a 90-minute budget, and hidden. The frontier tops out below half credit. The best model, Grok 4.5, averages 0.51 and also posts the best solve count, 13 of 46. So it's completing 13 of 46 tasks. 29 of 46 tasks have never been passed by any model. Price is not performance. Minimax M3 scores 0.39 at $6 per task, ahead of GPT 5.4 at $28 and other pricier. The signal lives in the partial credit, where binary metrics see how long is Long Horizon. Running all 46 tasks once takes each model 53 to 71 hours of wall clock time. A single task averages 69 to 93 minutes and 120 to 320 agent steps. The loop the model has to hold together. Without losing the thread, graph is showing the scale of one run per model, averaged over the 46 tasks. So the most steps, DeepSeek V4 Pro, then Minimax M3, then GPT 5, Grok 4, Tencent's HY3 model. So further down, okay, so Grok 4.5, 197. Down the bottom, Claude Fable 5. So the fewest steps is arguably the top model at the moment, which is quite interesting. So what are they saying here? Agents break at the horizon, not ask a frontier model to fix a failing test, and it usually can. Ask it to spend an afternoon bringing a scientific code base back to numerical parity, running simulations, reading regressions, adjusting, rerunning, and something different happens. The model does not lack the knowledge. It loses the thread. State drifts, earlier decisions are forgotten, exploration turns into looping, and the budget burns down with the goal half. Everyone who's worked with these agentic coding tools knows that sort of doom fixing, refixing, fixing. Existing terminal benchmarks rarely see this failure mode because their tasks can be short. A task that ends after a dozen actions measures whether an agent can start work. It says nothing about whether an agent can sustain it, carry state across hundreds of steps, recover from dead ends, and know when it is actually done. LHTB was built to measure exactly this regime. 3 design axes run through every task. 1. Long horizon. 2. Resistance. 3. Graded reward. So how have they put this benchmark together? what tasks are happening. Every task follows the same contract: a Docker container, an instruction file, a live environment, and a hidden test suite that grades the outcome. The 46 tasks span 9 categories: software and reverse engineering, scientific computing, earth climate and energy, multimodal and imaging, research reproduction, systems and security, professional workflows, and 2 that demand sustained interaction rather than a single artifact: interactive games played turn by turn, and logic and constraint puzzles solved by search. So we can see here what the 46 tasks cover and the count of tasks. What is an example of a task? The clearest way to see the design is through one concrete. In unison paper reproduction, the agent reproduces an experiment from the unison paper without being given the original. This is a research, and from the paper alone, build a parallel simulation pipeline, run the fat tree MTP experiment, match the tolerance, deliverables, a run fat tree CLI plus unison report JSON and summary CSV with counts, schedules, checks. Okay, structure here, environment setup, the test. So what is the evaluation setup? So comparisons are only meaningful if the scaffolding is identical. Every model runs through the same Terminus 2 harness, same prompts, same parser, same summarization policy, differing only in the API endpoint behind it. No model-specific tools, no bespoke agents, no retries. And what are the results that they found in running this benchmark? So the frontier tops out below half credit. So they're saying that across all these tasks, the best model isn't even getting half of the rewards they've made available for solving these tasks. Grok 4.5 narrowly leads a trio of Anthropic models, the GPT-5 series, and then there's a type pack of open weight and Chinese frontier models. Just the spread from first to last is nearly 2.5 across long horizon activity. We can now compare how the different models, these different providers, improve over the next year or so, until eventually at some point this benchmark gets. So they claim here partial credit shows the signal. Look at all 782 model task runs at once, and the case for graded rewards makes itself. Only 7% of runs cross the solve threshold. Under binary scoring, like a pass or fail, 93% of the benchmark would be indistinguishable zeros. The continuous reward spreads that mass out. More than half of all runs land in the low partial, where models differ by how far they get before losing the thread. The hardest tasks demand sustained quantitative feedback loops, run, measure, adjust, rerun, or evidence extraction from non-text. So on these hardest tasks across different domains, the average is here, but the best attempt by any model is here. And I think we can read into that different models are getting different performance in different domains as well. So this shows how even under benchmark testing conditions, different models have slightly different strengths and capabilities. The next result they find: price is not performance. The cost axis tells its own story. Per task spend ranges nearly 30 times, from $2.50 HY3 to $73 Claude Fable 5, while mean reward spans only 2 points. The twist: Grok 4.5 posts the top mean reward at just $11 per task. The Anthropic models pay the largest budgets for their scores, while a cluster around $4 to $12 delivers 60 to 80% of the top score at a fraction of the cost. And this cost versus capability, cost per task trade-off, is something I've been writing about a lot on my Substack newsletter, Getting AI to Work. A link to subscribe is in the description below. I've also been talking about this a lot on other videos I've made on this channel. Efficiency and not always getting the most expensive model to do a task for you is so important when it comes to getting the efficiency out of AI use. And it's super interesting that yet another benchmark is demonstrating how clearly this gap between most expensive and less expensive but almost as capable is becoming. It's even more interesting that Grok 4.5 is topping this specific benchmark, at a much lower price. That is extremely interesting. And if you in your business are thinking about the cost of your AI spend, it means you probably want to try Grok 4.5 for some of your development and agenda. So what are the takeaways? Long horizon completion is the real bottleneck. Across the models, runs average 231 steps, 9.9 million tokens in 85 minutes. Yet the best model still solves only 7 of 46 tasks at reward. Most failures are not immediate mistakes, but unfinished work. 79% of unresolved runs time out, while the agent is still actively making progress. Dense rewards are essential at this difficulty level. Under a strict perfect score threshold, 10 of the 15 models solve 0 tasks, even though many of their runs make substantial partial. So this has been a super interesting benchmark result, and it's going to be good to keep watching how this particular benchmark evolves over time, where AI as a drop-in remote worker to your business, it's not quite. And when we're looking at the agentic performance of different AI models and their harnesses, we know that we're getting different behavior based on which harness we use. So to my mind, it would be super interesting to run benchmarks like this with different harnesses to compare how much of that gap can be closed and how the rankings across models and their cost to complete each task vary with a harness different to the Terminus 2 harness that's been used in this particular run. It's a useful contribution to benchmarks. Benchmarks are complex and sometimes hard to understand. I think that anytime we have a new benchmark, it's always worth having a think about what it tells us. And what this tells us, there is still a long way to go on some more complex tasks. And as AI capability gets better, being able to see how different models change their rankings on benchmarks like this will help us better understand that relative performance. If you're using AI in your business, well, what does this mean? To my mind, it shows you don't want to just be using OpenAI or Anthropic models. You want to start experimenting with different models like Grok Minimax M.3, Kimi 2.7 code, GLM 5.2. If you're not experimenting with all of these, you're not going to find the optimal cost per task for the sorts of tasks you do in your business. When I write about change management in my newsletter, this benchmark type thinking is something that is always at the back of my mind, because operating models are about people, process, and platform. If we don't know how different models are performing on different types of tasks, we might set up workflows that are using the wrong model. They're too expensive. They're not capable enough. They're using the wrong harness. So this blend of technical and commercial is getting more important as we invest more into AI training. So if that's something that is interesting to you, you can hit that subscribe link in the description below, or hit like and subscribe on this video, and I'll be talking more about AI benchmarks and capability on this channel. Thanks for watching, and I'll see you in the next video.